To connect to 480 volts 400 amps 3-wire busways located on opposite sides of a metallic column or beam, you will need the following materials. Firstly, two 480 volts 400 amps 3-wire busways. Secondly, conduit or metallic raceway. Thirdly, flexible conductors sized appropriately for 400 amps. Fourthly, connectors suitable for the flexible conductors. And fifthly, a grounding cable sized for 400 amps. Now, let's go through the procedure. The first step is to take safety precautions. It is critical to ensure the power is turned off and the circuit is isolated. Always wear appropriate personal protective equipment, including gloves and safety glasses. Secondly, install the conduit or raceway. Mount the conduit or metallic raceway from one busway to the column or beam, ensuring it is securely fastened. Extend the conduit or raceway from the column or beam to the opposite busway. Thirdly, prepare the busways. Remove the end caps from both busways and clean the contact surfaces of the busways to ensure a good electrical connection. Fourthly, install the flexible conductors. Cut the flexible conductors to the appropriate length, ensuring they are long enough to reach between the busways through the conduit or raceway. Connect the flexible conductors to one busway using suitable connectors, ensuring a secure and tight connection. Repeat this process for the other busway. Fifthly, install the grounding cable. Connect the grounding cable from the grounding lug on one busway to the grounding lug on the other busway. This ensures proper grounding and helps prevent electrical hazards. Sixthly, pass the conductors through the conduit. Carefully feed the flexible conductors and grounding cable through the conduit or raceway. Ensure the conductors are securely routed and there are no sharp bends that could damage the insulation. Seventhly, connect to the opposite busway. Connect the flexible conductors and grounding cable to the corresponding terminals on the opposite busway, making sure to match the phases correctly. Tighten all connections securely to the recommended torque specifications. Eighthly, install the end caps. Replace the end caps on both busways to protect the connections and prevent accidental contact. Ninthly, power up and test. Before turning on the power, double-check all connections to ensure they are secure and properly installed. Turn on the power and test the continuity of the circuit using a multimeter to verify that the connections are correct and there are no short circuits. Ensure the circuit operates correctly and there are no overheating issues. Use a conduit or raceway with an appropriate size for the conductors to prevent overcrowding and ensure proper ventilation. Select flexible conductors with a sufficient ampacity to handle the current demand. Refer to the National Electrical Code, NEC, Table 310.15 for ampacity ratings based on conductor size, insulation type, and temperature rating. Tighten all connections to the recommended torque specifications using a torque wrench. This ensures a secure connection and prevents loose connections that could lead to overheating or arcing. Label the busways and conduit clearly for easy identification. This helps in future maintenance and troubleshooting. Regularly inspect the connection for any signs of damage or overheating, such as discoloration, melting, or unusual odors. If any issues are detected, immediately turn off the power and investigate the cause. When selecting flexible conductors, consider using those with high temperature insulation such as THHN or XHHW to improve their ability to withstand heat generated by the current flow. Ensure that the conduit or raceway is properly grounded to provide a safe path for fault currents in case of an insulation failure. Use grounding bushings or bonding jumpers to ensure continuous grounding throughout the conduit system. When connecting the flexible conductors to the busways, use connectors that are specifically designed for use with the type and size of conductor being used. These connectors provide a secure and reliable connection and help prevent loose connections or corrosion. When routing the flexible conductors through the conduit or raceway, be careful not to exceed the maximum fill capacity of the conduit. Overcrowding the conduit can make it difficult to pull the conductors and can also reduce their ability to dissipate heat. Consider using a wire pulling lubricant to reduce friction and make it easier to pull the conductors through the conduit. After completing the installation, perform a thorough visual inspection to ensure that all connections are secure, all components are properly installed, and there are no signs of damage or stress. If possible, Use a thermal imaging camera to check for any hotspots or areas of excessive heat. This can help identify potential problems before they lead to equipment failure or fire. Document the installation with photos and detailed notes, including the location of the busways, the size and type of conductors used, and the torque specifications for all connections. This information will be helpful for future maintenance and troubleshooting. Before energizing the circuit, inform all personnel who may be working in the area about the new installation and any potential hazards. Provide training on the proper operation and maintenance of the busway system. Consider using surge protection devices to protect the busway system from voltage surges caused by lightning or other electrical disturbances. These devices can help prevent damage to the busways and other connected equipment. Implement a regular maintenance program for the busway system, including periodic inspections, cleaning, and tightening of connections. This will help ensure that the system operates safely and reliably for many years. When working with electrical equipment, always follow all applicable safety regulations and codes, including the National Electrical Code and any local or state requirements. If you are not qualified to perform electrical work, consult a licensed electrician. Before working on any electrical equipment, always verify that the power is turned off and locked out using appropriate lockout/tagout procedures. This helps prevent accidental energization of the circuit while you are working on it. Use insulated tools when working on or near energized electrical equipment. This helps protect you from electric shock. Wear appropriate personal protective equipment, including safety glasses, gloves, and appropriate clothing. This helps protect you from electrical hazards and other potential injuries. Be aware of your surroundings and avoid distractions while working on electrical equipment. This helps prevent accidents and ensures that you can focus on the task at hand. If you are unsure about any aspect of the installation or maintenance of the busway system, consult with a qualified electrician or engineer. It is always better to be safe than sorry when working with electricity. After installing the flexible conductors, use cable ties or other suitable means to secure them in place within the conduit or raceway. This helps prevent them from shifting or rubbing against the conduit, which could damage the insulation over time. When selecting connectors for the flexible conductors, choose those that are compatible with the type of conductor being used and that are rated for the voltage and current requirements of the circuit. Use a crimping tool that is specifically designed for the type of connector being used. This ensures a secure and reliable connection. Before crimping the connectors, strip the insulation from the ends of the conductors to the proper length. Be careful not to nick or damage the conductors during the stripping process. After crimping the connectors, inspect them carefully to ensure that they are properly crimped and that there are no loose strands of wire. Use a continuity tester to verify that the connections are good. When connecting the grounding cable, use a grounding connector that is specifically designed for use with grounding conductors. These connectors provide a secure and reliable connection to ground. Connect the grounding cable to a suitable grounding electrode system, such as a ground rod or a building steel. This ensures that the busway system is properly grounded. After completing the installation, test the grounding system to ensure that it is functioning properly. Use a ground resistance tester to measure the resistance between the grounding electrode in the busway system. The resistance should be low enough to provide a safe path for fault currents. If the resistance is too high, investigate the cause and take corrective action. When selecting the size of the flexible conductors, consider the ampacity dilating factors that may apply due to the ambient temperature or the number of conductors in the conduit. Dilating factors reduce the allowable ampacity of the conductors, so it is important to choose conductors that are large enough to handle the actual current demand. Refer to the National Electrical Code for information on ampacity dilating factors. When installing the conduit or raceway, be sure to comply with all applicable building codes and regulations. This includes requirements for the type of conduit, the method of support, and the spacing between supports. Use appropriate fittings and connectors to ensure that the conduit system is properly sealed and protected from moisture and corrosion. After completing the installation, inspect the conduit system to ensure that it is properly installed and that there are no signs of damage or defects. Repair any defects or damage immediately. When working with electrical equipment, always be aware of the potential hazards and take steps to protect yourself and others from injury. Electricity can be dangerous, but it can be used safely if you follow the proper precautions. If you are not qualified to perform electrical work, consult a licensed electrician. They have the knowledge and experience to perform the work safely and correctly. Remember, safety should always be your top priority when working with electricity.